Hi everyone. This lesson is on equivalent values. Okay, so what we're going to look at as part of this is, remember from everything else that we've done, that we look at the present value to the future value. The future value is different because you're earning interest on the money that you initially invested, or if you have a debt, you're earning interest that you also have to pay back in addition to the loan that you took out. So at every day, every month has a different value for that same amount of money, all right, because of the interest being earned, or in some instances, the interest that hasn't been earned yet if you're going from the future value to the present value. That concept is known as the time value of money, okay? So what that means is that as your days change, like I say, further into the future or into the past, the value of your money changes. So what we want to look at is if we have a certain period of time, all right, remember our graph, okay? You have a certain period of time, say it's right here, okay? So we're in May 2020, and you know that you're making payments, okay? Maybe in June, July, August, and September, okay? Each of those payments technically is a different value. You might pay a certain amount, okay, in June. But if you want to know how much all of these payments would be worth in today, you have to take that and find the present value. Okay, if we're going back to the day, sorry, these arrows should all be going back to May. So for each of these periods of time, each of the times, June, July, August, September, that you make a payment, if you want to find how much all of that money would be worth at a certain point in time, let's call it today, May 2020, you have to discount that back or find the present value of each of those payments back to a certain point in time. So that point in time that we're talking about, in this instance today, is known as the focal date. And what you're doing is you're finding the equivalent value of each of these payments. Okay, it could be that you are adding $500 to a savings account each month. So in today's dollars, how much would that be worth as you keep adding money? Similarly, what we're going to look at is when you graduate, let's say you graduate in May, and you have to start making payments. June, July, August, September, a recurring payment to pay off your student loan. Well, that calculation is based on the time value of money. So you have a certain debt, let's say it's $20,000 here. How much do you need to pay every single month for the next several years to pay off that $20,000 loan now? Or it's worth $20,000 now. It'll be worth more in the future as it collects interest. So that overall is what we're talking about here. Okay, it's all about finding a specific day, okay, and translating all the different money periods that you have or investments you're making to a certain point known as the focal date. All right, so let's just take a look and review some of the formulas. So we have the formulas that we learned were the two formulas, present value, okay, and future value, right? Converting from one to the other. And the present value was just a manipulation of this future value formula. You can see that the 1 plus I to the exponent n is in the denominator, with the future value being divided by it. So if this focal date, okay, is after the due date or after the date that loan's due, you have to use the future value, okay? So picture back to our graph, right? So if this is the point in time where you are, your due date, and the date you're looking at is somewhere in the future, you need to go from your present value to the future value, okay? Now, if you're looking in the past, a good example of that would be something looking at like student loans. If you're going the opposite direction, let's say you're right here, that's your focal point, and your due date of this loan or investment is in the future, then you need to use the present value because you need to take your money and you need to discount it backwards to remove some of that interest that's earned on it, right? Because you need to find the present value, not the value it is in the future. So that's your basic set of rules, okay? So if you're going into the past, okay, the focal point's in the past, present value. If the focal point, the focal date is in the future, you use the future value. All right? Let's take a look at an example. So a sum of $4,000 is due for payment 3 years from now. If money is worth 9% interest per annum, compounded semi-annually, determine the equivalent value now. Okay, so there's a couple things to notice from this question. It says that a payment is due 3 years from now. In other words, 3 years into the future. And it's trying to find what the equivalent value is now. Okay, so if you think about your graph, you're sitting right here, okay, now, and your due date is 3 years in the future. So this is year 3, and we'll call today year 0. So because it's in the future, right, and we know that your loan is for $4,000, we want to figure out how much that is now, right? Because if you have that sum sitting there for 3 years, it's going to earn interest. So you have to take that interest off. If you know, since we know in this question that it's due $4,000 here, we want to find the present value here. And I'll put present value and I'll say year 0. That's where I use the subscript 0. So knowing that we have to go into the past, it means we have to use the present value formula. So I always start by writing the formula. In this case, I included it in the slide. The present value is equal to the future value divided by 1 plus the interest rate. Remember, that's the periodic interest rate. And that's raised to the exponent n, which is the total number of compounding periods. So just like we did in previous examples, now that we have the formula, we have to figure out what we know. So we know that our future value is equal to $4,000. That was provided in the question. We know that our nominal interest rate, also provided in the question, is 9%, which is equal to 9 divided by 100, removing the percentage sign, which is equal to 0.09. Our number of compounding periods per year, okay, that's also provided in the question, is semi-annually. So semi-annually means twice per year. So now that we have that, we can calculate our periodic interest rate, which is equal to J divided by M, which is equal to 0.09 divided by 2, because we have semi-annually, 2 compounding periods per year, which is equal to 0.045. So now our last term we need, just like our other questions, is our total number of compounding periods, n. So that is the number of years multiplied by the number of compounding periods per year, m. So we know in this question, it's 3 years from now, so the number of years is 3, and our number of compounding periods is 2. So our value for n becomes 3 times 2, which is 6. So substituting those values into this formula, we get our present value is equal to our future value, $4,000, divided by 1 plus 0.045, our periodic interest rate, and that's raised to the exponent 6. So when we calculate that out, we get a present value of $3,071.58. And we stop and think, does this value make sense? Well, if we have a sum of money that's worth $4,000 3 years from now, it would be worth less today because you're earning interest on it. Okay, so that number makes sense. So let's look at a second example. Frank was supposed to pay off his debt of $10,000 8 months ago. Determine the amount his debt is worth now if interest is 6% per annum compounded monthly. Okay, so again, I like to start with these graphs. You don't necessarily have to. Okay, I just find that it helps me figure out whether or not it's in the past or in the future. So we figure out whether we use the present value or the future value formula. So we know in the question that his debt is $10,000. So that's the amount we're working with. And it was due 8 months ago, right? So he hasn't paid it yet. His due date is right here. And where he currently sits, this is now, is 8 months in the future. So we know that we want to figure out, okay, what his value is now. Okay, so because his due date was before the time period it is now, okay, we know at the due date it was $10,000, right? And we want to figure out what it is now. So in other words, we're going into the future, right? From where his debt was. It was $10,000. We're going into the future to figure out how much it is now, which means we have to find the future value of that money since we know the present value as of 8 months ago. Okay, and you'll see when you get your answer, if you read this question, he was supposed to pay off his debt 8 months ago, and you know that if you don't pay your debt off, you earn more interest on it, right? So you'll figure out when you get to the answer of this question, it's going to be a number that's larger than $10,000. And that makes sense, right? Because you have earned additional interest by not paying your debt off in time. All right, so now that we've figured out that we're trying to find the future value, we're going to start with the formula. So the future value is equal to our present value times 1 plus the periodic interest rate. And that's all raised to the exponent n, okay, the total number of compounding periods. So we start with what do we know? We know our present value, or the value when it was due, was $10,000. Our nominal interest rate provided in the question, okay, 6% per annum, and that's equal to 6 divided by 100, removing the percentage sign, which is 0.06. Our total number of compounding periods, m, is also given in the question. It's compounded monthly. So if it's compounded monthly, there's 12 months in a year. So our number of compounding periods per year is 12. Now we can calculate the periodic interest rate, I, which is equal to j divided by m, which is 0.06 divided by 12. And if you calculate that out, you get 0.005. All right? Lastly, we need the total number of compounding periods, n. Okay, and that's equal to the number of years multiplied by our number of compounding periods. So we've provided in the question that it was 8 months ago. So if we convert 8 months to years, 8 months, and that's divided by 12, okay, because there's 12 months in the year. So I'm going to keep it as a fraction just to substitute it into the formula. You'll see why in a second. So our total number of compounding periods is equal to 8 divided by 12, and that's multiplied by our number of compounding periods per year, which is 12. So the reason I kept that is because 8 divided by 12 would actually give you a repeating decimal, 0.6666. And when you calculate it out, you should get an even number of compounding periods, right? Because you have 8 divided by 12 multiplied by 12. And remember, if you have the same number in the numerator and the denominator, those can actually cancel out and they just become 1. So your value of n is 8. Alternatively, you could plug that into your calculator, but in this case, because I left it as a fraction, I get a whole number as opposed to any rounding that might happen if you had rounded the 8 divided by 12. Okay? So now I have all the values I need, so I'm going to substitute it into this formula. So our future value is equal to our present value, and that's the value we know in the question, which is the value when the debt was due, $10,000. That's multiplied by 1 plus our periodic interest rate, 0.005, and that's all raised to the exponent 8, right? Total number of compounding periods. If you calculate that out, you get a future value of $10,407.07. And again, I go back to what I said at the start of the question. Does this number make sense? If you think in your head, he didn't pay his debt off of $10,000, and it's 8 months past. So it should be a number that is greater. If you had used the present value formula, you would have got a number smaller than $10,000. And when you stop and think about that, you know that that can't make sense. Or everybody would just never pay their loans off, right? Because it would be a lesser value the longer you waited. Okay? So let's look at another example. I actually have 5 examples for this before we get into another piece. looking at some equivalent payments. So let's look at our third example. Joanna plans to pay off a debt by payments of $1,600 1 year from now and $1,800 18 months from now. Determine the single payment now that would settle the debt if money is worth 8% interest per annum, compounded quarterly. So again, going to start with a graph. So we're here, okay? I'm going to call it year 0. And we don't know what the payment is now. But what we do know is that Joanna's looking at paying off a debt with 2 other payments. Her first payment is 1 year from now, so year 1. And that payment is $1,600. And her second payment is 18 months from now. So 18 months, converting that to years, just to make things a little bit simpler, divided by 12 months in a year, you actually get 1.5 years. So if I go down the road here to year 1.5, her second payment is $1,800. So what you'll notice is both of these payments are in the future. All right. The date that we're trying to find, because we're trying to find a single payment now. So we're trying to say, instead of making a $1,600 payment in 1 year and an $1,800 payment 1.5 years from now, we need to find the equivalent value of those payments today. So that means we're moving into the past. So we know future values, the $1,600 and the $1,800, and we're moving into the past. So that means we need to use the present value formula. All right. In this case, we're actually going to have 2 calculations. We need to convert both of these payments into present value. So I'm going to start with our formula. We have our present value is equal to our future value divided by 1 plus periodic interest rate, and that's all to the exponent n, the total number of compounding periods. Now we're going to do this calculation twice, okay? One for the $1,600 payment and one for the $1,800 payment. And the reason we're going to do 2 separate calculations is they actually have the same interest rate, but because they're not done at the same time, they have a different number of compounding periods, okay? So I'm going to start with the $1,600 payment first. All right. So for that one, okay, I can actually show both of these here. So for the first payment, we know that our future value is equal to $1,600. We know that our nominal interest rate is 8%. It's provided in the question. And that's equal to 8 divided by 100, removing the percentage sign, which is equal to 0.08. Our number of compounding periods, m, okay, it says in the question that we're compounding quarterly. So quarterly, remember, every 3 months. So that means a total amount of compounding periods per year of 4, right? So knowing that, we can actually calculate our periodic interest rate. It's equal to j divided by m, which in this case is equal to 0.08 divided by 4, which is equal to 0.02. Now the last item we need is the total number of compounding periods, and that's n. So n is actually equal to the number of years multiplied by the number of compounding periods per year. And in this case, we have 1 year, okay, because it's a year ahead, and we have 4 compounding periods per year, so our value for n is 4. So that is for our payment number 1. Okay. For our payment number 2, our future value is equal to $1,800. And you'll notice, all right, because we have the same interest rate, okay, and the same number of compounding periods per year, they're both quarterly, those values are going to be the same. So our nominal interest rate is still 8%, which is equal to 0.08, just like I did here for payment number 1. Our number of compounding periods per year, again, is 4. So that means we have the same numbers for J and M. So what you're going to notice is our periodic interest rate will also be the same. It's equal to J divided by M, which is 0.08 divided by 4, and we get the same number of 0.02. The item that does change is your total number of compounding periods, N, because that is the number of years multiplied by your number of compounding periods per year. And our number of years for the second payment is 1.5, right? Because we're 1.5 years ahead of the time period we are right now. So our N becomes 1.5 multiplied by 4, the number of compounding periods per year, and that is equal to 6. So, like I said, we have to take both these payments and find the present value. So to do that, okay, our present value, remember our formula here, we can take that a step further. So our present value, our total one, would be equal to our present value of payment number 1 plus our present value of payment number 2, right? We can just add them together because we are already converting them or discounting them back to this period. Both of them are being discounted at the same period, so we can just add them together. So what I'm going to do is we can do this all in one calculation. So our present value is equal to our present value for payment 1, right? That's our future value, $1,600, divided by 1 plus our periodic interest rate, 0.02, and that's raised to the exponent 4. Okay, that's our present value for payment 1, plus our present value for payment number 2, which is $1,800, divided by, again, 1 plus 0.02. The difference here is this is raised to the exponent 6, right? Because it's further into the future. So if you calculate those out, all right, you'll get a total, or actually I'll do each calculation first for you. So we'll get a total, and I'm doing it at the same time as you. Our first item is $1,478.15. That's present value number 1. And you have present value of number 2. And I'm doing it at the same time as you, just so you know, in case you can hear my clicking, is $1,598.35. So if you add those two together, and I'm doing it at the same time, but I'm going a little too fast on my calculator, you get a present value of $3,076.50. So you'll notice that instead of paying $3,400 off, $1,600 plus $1,800 in the future, she's saving money by paying off her debt early. The same would go for you if you look at an example and you're paying off your student debt. Okay? Okay, let's look at example number 4. Debt payments of $400 due 5 months ago, $600 due today, and $800 due in 9 months are to be combined into one payment due 3 months from today at 12% compounded monthly. Determine the equivalent value of the combined payment. So this one is even more important than the previous questions to start by drawing a graph. All right. So what we'll see is if you read the question, you've got payment that's in the past, 5 months ago, a payment today, and a payment in the future. And what we're looking at is combining it into one payment that's due 3 months from today, so in the future. So if you start with the graph, all right, so I'm going to pick the middle here as today. And we know that we have a $600 payment here. We also know that we have a $400 payment 5 months ago. So we'll call this, well, I'll call it minus 5 months because it's 5 months in the past. And we know we have $400 here. And we know that 9 months from today, or in other words, 9 months ahead, I'll say positive 9 months here, we have a payment of $800. So these are the 3 payments that you have to make. Now what the question is asking is that they are to be combined into one payment that's due 3 months from today. So 3 months from today would be in the future, so plus 3 months. And you don't know what that payment is. Okay? So you need to figure out now what the value of each of these three payments is, the $400, the $600, and the $800 at the period of time 3 months from today. So that means that your first payment that was due 5 months in the past, you have to move that one forward. Okay, so that means you're finding a future value for it because you're finding it in the future. Your second payment today of $600, again, you're moving it forward 3 months, so that's a future value. And your last payment of $800 hasn't been due yet. It's due in 9 months, right? So that payment you're moving in the past 6 months in order to place it at this period of time that the question is looking at. Again, this is about equivalent values. So you're trying to translate each of your payments to one period of time. So what that means is we have three calculations. We have to do a future value calculation for this payment that was 5 months ago, another future value payment for the payment today because we're looking at a period of time 3 months from now, and then we have to do a present value calculation for this third payment, all right, that's 9 months into the future. So what that means is that our total payment is equal to our future value calculation, and I'll call it payment number 1, plus our future value calculation for this second payment, payment number 2, the $600, plus our present value calculation for payment number 3, which is the $800 9 months from now. So we have three separate calculations that all will be added together to find that value in 3 months from now. So we'll start by writing out each of those formulas. So our payment, and I'm just going to write them each here, is equal to future value calculation number 1, right, which is our present value at that period 1, times 1 plus our periodic interest rate raised to the exponent n, our total number of compounding periods for this payment, plus our future value calculation number 2, which is our present value for item number 2, multiplied by 1 plus our periodic interest rate. And again, that's all raised to the exponent n, a different number of compounding periods though. Remember, it's at a different period of time, it's today. Plus our third item, which is our present value calculation for this last payment of $800 9 months from now. So that's equal to that future value, the payment number 3, the $800, divided by 1 plus the periodic interest rate, and that's all raised to the exponent n, though the total number of compounding periods for that payment. Now, just like the last question, okay, for this question, it was provided that our nominal interest rate is 12% and it's compounded monthly. That's for every single payment, all right? So what that means is our periodic interest rate, I, will actually be the same for all three calculations. So we only have to do that calculation once, all right? So again, I'm going to go off to the side here and I'm going to do calculation number 1, okay? So this is number 1. We know our present value for that calculation is $400, the amount provided in the question. And we know I'll do the periodic interest rate calculations for this one. Again, it'll be the same for all of them. We know our nominal interest rate is 12%, which is equal to 12 divided by 100, removing the percentage sign, which is 0.12. We know our number of compounding periods is monthly, provided in the question. So our value for m is 1. So now we can calculate our periodic interest rate, which is equal to j divided by m, which is 0.12 divided by 12. All right, and if you calculate that out, you get a value of 0.01. Now for this first payment, all right, our total number of compounding periods, n, is equal to our number of years multiplied by our number of compounding periods, m. So if I convert this, all right, n, our total period of time, all right, we're going from, we have 5 months to get to today. I'll do this in a different color actually, I'll do it in purple. But we're looking at a payment that's 3 months in the future from today. So we have to go another 3 months into the future. So our total amount of months is 5 plus 3, which is 8 months, right? We're moving this payment up 8 months to that period in time. So going back to our problem, that means we have 8 months, and this is number of years. So we have to convert the 8 months to years. So to convert that, there's 12 months in a year. So we have 8 divided by 12. In this question, because we're being compounded monthly, we're being multiplied by m, which is 12. So just like we did in the past question, these 12s would cancel because there's a 12 in the numerator and a 12 in the denominator, and we get a value of n of 8. You can also calculate this out using your calculator without doing this cancellation. It's totally up to you. All right? So this is for present value payment number 1. So we need to actually calculate this out for the other 2 payments. So I'm going to switch slides. I'm going to write out some of the items on the next slide, and we'll finish our calculation. Okay. So remember, for our first calculation, we had our present value was $400. We calculated our periodic interest rate, and that was 0.01. And our number of compounding periods was 8. All right, that was just the information I translated from the previous question. So, or previous page, sorry. So if we look back to our graph, we have this payment, which is minus 5 months of $400. That's the one we just calculated. We've got our payment from today, which will be our next calculation, which was $600. We have our third payment that's due in 9 months from today, plus 9 months, and it's $800. And we're trying to translate all of those to a period of time, 3 months from today. So that's the value we're trying to find. So we just did payment number 1. Now we're going to look at payment number 2. So again, because our second payment is also in the past, compared to the period, the focal date we're looking at, which is 3 months ahead of today, it's also a present value calculation. So our present value was provided in the question for this, $600. Our interest rate, periodic interest rate, doesn't change, and it won't change for any of these, right? It stays as 0.01. But what does change is our number of compounding periods, n. Okay, so n is equal to the number of years multiplied by the number of compounding periods, m. And just like in the past, our periodic interest rate question didn't change, so neither does our number of compounding periods per year. Because in the question, neither of those values changed for each payment. So again, if we look at this, we're looking at today, and we're looking 3 months into the future. So our total distance we have to go is from today to 3 months in the future. So a total of 3 months. So our value for n is equal to 3, and we have to convert that to years. So 3 divided by 12, right? 12 months in a year. And that's multiplied by our number of compounding periods per year, which did not change. It was equal to 12. So just like previously, those 12s will cancel, and we end up with a value for n of 3. All right? Now, okay, we have payment 1, we have payment 2. Our last item is payment number 3, which is the item that was in the future. Remember, since it was in the future, we have to do a present value calculation for that payment. So if we look at payment 3, that means because it was in the future, that we know the future value for this payment, 3, is $800. Just like in the previous questions, our previous payments, our periodic interest rate doesn't change. It's 0.01. And our number of compounding periods per year doesn't change as well. It's 12. But the number of compounding periods, total number n, does change. And that's equal to our number of years multiplied by our number of compounding periods per year. So in this case, we're going from 9 months ahead of today to 3 months ahead of today. So that means our total amount of time we're moving back to the present is 6 months, right? This is moving 6 months into the past. So if we convert that into in our formula, we're moving 6 months divided by 12 months per year, because we have to convert it to years, multiplied by our number of compounding periods per year, 12. And again, the 12s cancel, and you get a total number of compounding periods of 6. So now we know all of the variables for each of our 3 payments. So remember our original formula, our total payment was equal to, our future value calculation for payment number 1, plus our future value payment for payment number 2, plus our present value of payment number 3 because it was in the future. So that was equal to present value for payment number 1 times 1 plus the periodic interest rate to the exponent n, the total number of compounding periods for that payment, plus our present value for payment number 2 multiplied by 1 plus the periodic interest rate I, again, raised to the exponent n, the number of compounding periods for that payment, plus our present value calculation for payment 3, which was the future value for that payment divided by 1 plus the periodic interest rate. And that's all raised to the exponent n, the number of compounding periods for that question. So if we substitute all of our values in, we get present value 1, 400, times 1 plus 0.01, and that's to the exponent 8, plus our second payment, $600, times 1 plus 0.01, again the same interest rate, that's raised to the exponent 3. And our third calculation, which is $800, divided by, because remember it's present value, 1 plus 0.01, and that's all to the exponent 6, right? Because there's 6 compounding periods for that item. So if you calculate each of these values out, you get your first payment is equal to $433.14. Your second payment is equal to $618.18. I'm just simplifying each of these, okay? And your third payment is equal to $753.64. So now you add all those together and you get what the payment would be 3 months from now. And I'm sorry, I'm running out of space. But if you do that, you get a total value of $1,804.96. So that is actually the amount you would have to pay in that period 3 months from now to pay off this whole debt. So you can see this was our 4th example. This is the reason I'm doing 5 examples for this, is each time it gets slightly more complicated as we add an additional variable or an additional item to consider. In this question, we had both future value calculations and present value calculations. Okay? Okay, so let's look at our 5th example. And this one, again, adds a little bit more complexity. Scheduled debt payments of $1,000 due today and $2,000 due 1 year from now are to be settled by a payment of $1,500 3 months from now and a final payment of 18 months from now. Determine the size of the final payment if interest is 10% per annum compounded quarterly. So you'll see here we have scheduled debt payments, okay? And instead of actually paying those off at the scheduled times, you're paying them off with 2 separate payments, one that's provided in the question of $1,500 and a final payment which we need to figure out what it is. And like I said, in every other question, the easiest way to see this is to visualize it. All right, so I'm going to start and I'm going to pick the starting point. This is today. All right, and you'll notice starting in the question, you have a $1,000 payment today. And you have your second payment, $2,000. Okay, I'm going to move further down. Let's say year one. You have a $2,000 payment. And those are what the payments you had to make that were due. To settle those payments, okay, your next piece is that your first payment's $1,500 and it's 3 months from now. So I'm going to say plus 3 months. And it's a payment of $1,500 to pay this debt off. Okay, so that's actually minus $1,500. And I'll go into why that is in a second. Your last payment is due 18 months from now. So again, 18 months. Converting that to years, divide it by 12. 12 months in a year. That's 1.5 years. So I'm going to say here, year 1.5. We don't know what that payment is. All right. So in the question, it's looking at the size of the final payment. So that means that your focal date is this year 1.5. So each of your payments here, each of your items have to be moved forward. So you have to find future value for each of these 3 payments. Okay? So in general, this is a debt, right? So you want your debt to be equal to 0. Okay? So what, in other words, you have, if you're writing this down as a formula, you're doing 3 future value calculations. So you want your amount that you pay to be equal to the amount that you owe after they've all been moved to this period of time. So if you start, right, so the amount you owe has to be equal to the amount you pay. Now, if these were just, add today and all the values were as of today, you could technically add them up. But we need to find them as a value at the same time period, which is this year 1.5. So the amount you owe, right, is a payment due today, this $1,000, and a second payment that was due 1 year from now, which is $2,000. Okay, so both of those, in order to find them as of this year 1.5, are future value payments. So you have your future value, payment number 1. We'll call these payments 1 and 2. Okay, those are your debt payments, and we'll call the actual payments you make here, payment 1 here, and payment 2 here. So the future value of the payment you owe today plus the future value of the payment that you owe in 1 year have to be equal to the 2 payments that you made. So the payment you made in 3 months from now, so we'll call that the future value. We'll call it payment 3, actually, instead of payment 1. I'm going to erase that. Call this payment 3. Plus the amount at your time period, item number 4. Okay, so that is, I'm just going to call it payment 4 because it's already the same day as the focal date, right? Because our focal date is the date of that last payment. So what I'm going to do is the item we're trying to find is payment number 4. So I'm going to rearrange this equation by subtracting this future value of payment 3 from both sides. Okay? So those cross out on that side. So your payment number 4 must be equal to those 2 debt payments, the future value 1 plus future value 2, which are the $1,000 and $2,000 payments, minus the payment that you've made. Okay, you're going to make a $1,500 payment that's provided in the question 3 months from now. All right, so we have 3 future value calculations that we now have to do. All right, we'll start by doing the first one, and I always like to do them from left to right as opposed to this graph. Okay, so we're going to do future value of payment number 1. So let's look at payment 1. And that one, we know that our present value is $1,000. Okay, because that's how much would be due today. Our interest rate, our nominal interest rate, is provided in the question. Okay, it's 10% per annum, so 10%. And just like in the previous questions, the interest rate and the compounding periods don't change. So this value of the nominal interest rate and the number of compounding periods will be the same for each one of your payments. So this is equal to 10%, which is 10 divided by 100, removing the percentage sign, which is equal to 0.10. Your number of compounding periods per year, M, it's given in the question that it's compounded quarterly. So quarterly means your number of compounding periods per year is 4. So you can calculate now your periodic interest rate, which is equal to J divided by M, to 0.10 divided by 4, which is equal to 0.025. So if your last item you have to calculate is your total number of compounding periods for this, N, which is equal to the number of years multiplied by your number of compounding periods per year. Well, we know we're looking at this first payment is today, and we're looking 1.5 years into the future. So our number of years is 1.5, and our number of compounding periods per year that we calculated was 4. So our value for N, in this case, was 6. Okay, so that is for this first scheduled debt payment. All right, the next one, I'm going to move to the next page. All right, I'm going to write our formula again on the next page, and we'll look at doing the next one in order. So our payment 4, like I wrote in the last, is equal to our future value for the first one payment plus our future value of the second payment minus what you've already paid off, future value of payment number 3. So remember, we had our graph drawn, and we had today, that was payment number 1. Then we had 1 year from now, that was payment number 2. Okay, keep in mind, these are when you were supposed to pay your debt off. The other 2 payments are when you're actually paying it off. All right, so instead of doing the scheduled payments, you're paying them off at a different period in time. The third one, your first payment that you made was actually three months from today. That we're calling item 3. And now our last payment that you're going to make instead of your scheduled payments was 1.5 years from now. That's also the focal date or the period that we're trying to find, and that's payment number 4. And the values for each, for the first payment was $1,000 and the second payment was $2,000. Now what you've actually paid off was you paid off $1,500 here, and you're trying to figure out what your last payment is. This is just everything that I've done from the previous slide. So we did our first payment, right? If you remember, for payment 1, oh, wrong color. For payment 1, we had our present value for payment 1 is $1,000. Our periodic interest rate was 0.025. Our number of compounding periods, M, was 4. And our total number of compounding periods was 6. Okay. Now the values for I and the value for M, again, because they didn't change in this question, right? The 10% and the quarterly stayed the same. The values for I and M will be the same for all of your payments. Okay. So let's look next. We just did this first one. Let's look at what I'm calling payment 3, the first payment you made. I'm just moving from left to right. Okay. So it's payment 3. Our present value for this is $1,500, right? That's how much we paid off. And again, I wrote a negative here, but that's just symbolizing that you reduced your debt. So when we rearrange this formula, we have it being subtracted, which means we can keep everything consistent and not have to change the signs in our formula. So our present value is $1,500. Like I said, our periodic interest rate does not change for each of them, so it's 0.025. Our number of compounding periods doesn't change either, it's 4. And our number of compounding periods for this one, all right? If you look at this question, it's 3 months from today, and it's 1.5 years. Okay, the final date is 1.5 years. So what this means is 1.5 years from today, there's 12 months in a year, multiplied by 1.5 years. That means it's 18 months away. And since we're 3 months into the future, we subtract 3 months off. So that means we're actually going 15 months in the future for this payment number 3. Okay? So I'm going to substitute that into our formula for n. Okay, 15 months. And remember, we have to convert it to years. So I'm dividing by 12 months in a year. And that's multiplied by m, which is given in the question, as 4. Okay, so if you multiply that out, you'll get an answer of 5. In other words, we have 5 compounding periods total for our payment number 3. Moving next, okay, we're looking at what I'm calling payment number 2. Okay, it seems kind of confusing that we're calling all of these payments. Okay, but keep in mind the big difference here is that payments 1 and 2, those were the scheduled payments, like I've said. It was when you're supposed to pay it. Payment 3 and 4 are when you're actually paying. So say you missed a payment. Okay, so instead you're paying them off at a slightly different period. That's why they're different terms. I keep thinking in my mind as I'm doing this question that that's probably confusing you. So let's look at payment 2. And again, these are your scheduled payments. 1 and 2 are your scheduled payments. Your present value, the amount you're supposed to pay off at that period of time. Whoops, wrong color. The amount you're supposed to pay off at that period of time is $2,000. Your periodic interest rate does not change, 0.025, and neither does your number of compounding periods per year. It's 4. What does change is the value of n, your total number of compounding periods. In this instance, we're at year number 1, and we're going to year 1.5, right? So we're going half a year into the future, which is 6 months, okay? So we're going 6 months into the future, or half a year, but I'll show it as 6 months, and we have to convert that to years. So 6 divided by 12, because there's 12 months in a year, multiplied by the number of compounding periods per year, which is 4. You calculate that out, you get a value of n of 2. Okay? So now that we have the values for all 3 of these payments, we can substitute them into our equation and solve it. So I'm going to substitute it. Again, I'll do it in a different color. Payment number 4. I'm writing as that instead just to save some space. That's equal to our future value calculation for time number 1, which is $1,000. Okay. Actually, I'll write the formulas out first. So it's equal to our present value for number 1 times 1 plus our periodic interest rate to the exponent n, and that's the number of compounding periods for that payment, plus future value calculation number 2, which is present value for scheduled payment number 2, times 1 plus the periodic interest rate to the exponent n, plot minus, okay, present value for item number 3. Again, that's the amount you've actually paid off to reduce your debt. That's why it's being subtracted. times 1 plus the periodic interest rate, and that's also raised to the exponent n. Again, these n's are all different depending on how many compounding periods for each one. So if we substitute our values, payment number 4 is equal to $1,000 times 1 plus 0.025, and that's all to the exponent 6, plus 2,000 times 1 plus 0.025, and that's all raised to the exponent 2, minus, again, sorry, I'm running out of space, so I'm going to write this just below, minus payment number 3, so $1,500 times 1 plus 0.025, and that's all raised to the exponent 5. Okay, so all I've done is substitute those values in. So what you end up with, okay, if I simplify each of these expressions, our fourth payment is equal to this first item, which comes out to $1,159.69, plus our second payment, which comes out to $2,101.25, minus the amount we're paying off, okay, which is $1,697.11. So if you put those in your calculator, you get that your final payment to pay off your debt must be $1,563.83. Okay? So that means that if you pay that off at this final period of time, 1.5 years from now, that's the remainder of what your balance would be.